Greetings viewers, welcome back to the channel. In today's video we've got something a little bit different. Normally over the past few years on the channel we've been talking about EJ series engines, we've talked about EZ series engines, but we haven't had much content on the new FA and FB series engine platform. They've just been too new to be able for me to buy junky cheap Subarus to repair like the EZ cars. I mean, I can go out right now and buy Outbacks and Prezas, things of that nature from the early to mid 90s for a couple $100, and I've got lots of content to make videos, repair videos, and things of that nature. I've also accumulated quite a bit of Subarus out in the Subaru junkyard, Subaru ranch out there. I think I've got 16 or 17 Subarus right now. Actually, I think it's 18 counting the sandbar. I've lost count. There's how many Subarus I've bought and sold over the years. So again, as I said, we haven't talked a lot about the FA and FB. We've gone over some stuff in the past talking about what's different on them, some issues on them, but not a lot of repair stuff, especially not engine related stuff. So as you see behind me that my arm is slung over, I have an FA20 short block. This was graciously donated to me by my buddy Stuart that is at Shift Fast Motorsports, Rock Hill, South Carolina. If you're in the Southeast and need any Subaru performance work, tuning, any of that stuff done, hit up Stu at Shift Fast Motorsports. They are the place to go to. But this is an FA20. It came out of a BRZ. It has a spun rod bearing. It was tossed in the scrap metal bin. He said, hey, I've got an F-Series engine. If you want it, come grab it, pull it out of the scrap metal bin, and it's yours. So that's what I did yesterday. Went and grabbed this engine. The last hour or so, I've been cleaning it up because it was a bit corroded from sitting out in the weather for the last few weeks or a month. I'm not exactly sure how long I've been out there. But I got it freed up, got it turning. There is some rust on the crankshaft, and as some of you saw in the community post, there was some rust in the cylinder liners. So with that said, we're going to take a look real quick at the FA20, and we are going to look at the spun rod bearing, and we're also going to remove that rod and piston from the block, take a look at the damage, and that'll be basically it for this video. I plan to do a FA versus EJ video in the future, very soon, hopefully. It'll probably be a series of videos comparing the differences between the FAs and the EJs. But with that said, let's get in here and take a look at this spun rod bearing that failed on this BRZ. Alright, so we've talked in the past about lots of differences between the F-Series and EJ Series engines, but really quickly, just hitting a few things. On the EJs, your oil pump set here, bolted to the front of the engine block. On the F-Series engines, it's in the front timing cover. Biggest difference is EJs were a timing belt engine. The F-Series engines are timing chain engines. You may be able to see a little bit of the RTV still here. Lots and lots of sealing surface, lots of areas that possibly can develop oil leaks in the future on F-Series engines. A downfall, but one good thing, you don't see the water pump here like on the EJs that was bolted to the block and driven by the timing belt. F-Series engines use an external belt-driven water pump, so you don't have to mess with the timing set to change the water pump. We've got these pegs here. These pegs are for the timing chain guides. You have a tensioner that sits here pushing down on a guide. We have a tensioner here that pushes up on a guide this way. Let's turn the engine. Actually, let's look back here. Most of you that have worked on any EJ Series engine are aware of this cutout here. This is to access the bolts that go through the flex plate into the torque converter on automatic transmission models. You may not be familiar with this cutout over here. This cutout here is for the crankshaft sensor. If you've worked on EZ Series engines, you will be familiar with this system. EZs use have the crank sensor mounted at the bell housing end of the engine block. There's a reluctor wheel back here on the back of the crankshaft that sends the signal through the crankshaft sensor. If you're used to EJs, you're used to the crank sensor sitting right here. It's set in the front part of the oil pump, and then the reluctor was made into the backside of the timing gear for the timing belt. So coolant crossover pipe, pretty much the same between EJ and F-Series. You have a pipe bolts across here for the coolant to flow. It's pretty much the exact same location and setup. The PCV valve is pretty much in the same location with the oil air separator plate on the back side. So let's rotate the engine really quickly. Hopefully I don't make a mess and knock everything off the toolbox. Seems something fell. Okay, so back here at the back of the block, as we said, our PCV valve mounts back here. This is the oil air separator plate. It is pretty much in the exact same location as on the EJs, but it is a much smaller and different shaped oil air separator plate than what we saw on the EJ series engines. You'll also note that there is no piston pin access cover here, nor is there a plate here like on the EJ series engines. That comes down to the new designed piston rods. We'll get to that when we actually pull it apart, and why these engines assemble differently than the EJs, where if you're familiar with rebuilding or taking apart an EJ series engine, you have to reach in through access covers, pull the circlip, and pull the piston wrist pin out through the engine block, pull the piston heads out, disassemble the block, split the block in half, and remove the crankshaft with the rods bolted to it. That's completely different on the F-Series engines, and like I said, we'll get to that when we get underneath here to pull out that spun rod. Let's turn the engine again as I knock everything off behind. Got too much stuff on top of my toolbox. Really quickly, we'll look at the cylinder liners. They are a lot thicker. Well, not a lot thicker, but they are visually notably thicker than the cylinders on the EJ series engine. This is a 2-liter compared to most EJs being 2.2 or 2.5, although there was a 1.8, a 1.6, and a 2-liter, but I don't have an EJ20 here to show, and I don't have one for the comparison video. I've got an EJ18, an EJ22, and an EJ25 handy, so I'm either going to use the 18 or the 22 for the comparison. We'll rotate the engine really quickly to show you some differences of the pistons. As you see, the piston actually protrudes above the deck surface. It has a little bit more deeper of valve reliefs in the piston. And you also get this odd wedge shape here. That is for the direct injection fuel injector, where it sprays into the combustion chamber directly rather than the EJs being a port injected engine. But again, we'll look more between EJ and FA pistons when we get this removed. So the issue with this engine was, as I said before, it spun a rod bearing, and it spun a rod bearing right here on cylinder 2. So we'll rotate the engine again. Let me flip it up top side. Trying not to scratch the crap out of my toolbox top. All right, so another really quick difference, something that this engine shares with the EZ series engines. You see that, or you might be able to see the difference in the bottom of the small block engine block area. These engines actually use a two-piece oil pan like the EZs do. They've got an upper pan made of aluminum, and they got a lower pan made of steel. So that's why you see the O-rings and this large area of RTV where it seals. But to the rods, so cylinder 2 over here, we'll look at cylinder 3 really quickly. As you see, I can grab it, and it is solid. I'll grab number 2. Let me get closer with the mic. See if you can pick that up. But that is our noise in this engine. That is the fault with this engine. We spun a rod bearing on cylinder 2. That's why the engine was removed and replaced. So that said, we're going to go ahead and remove this rod, take a look at the crankshaft, see the damage on the crankshaft, see the damage to the bearing, and look at the difference in the design of the rod and the piston. Again, if you worked on EJ series engines, you know that you cannot access this, the big end of the connecting rod with the rod in the engine block. So these are a little bit different. They use an E14 inverted Torx fastener rather than a regular hex. Let's go ahead and break this loose and pop this rod out of here. There we go. All right. And that's our problem right there. That rod bearing is eaten up and has spun on the crankshaft. So let's go ahead and move this to the side really quick and perhaps reposition this a little bit better before we go ahead and attempt to push this piston out. Hopefully it comes out fairly well. There was a little bit of a ridge of rust in the cylinder bore from it sitting out in the elements. There's one bearing. I'm trying to be careful. These things are super sharp and worn down. Definitely don't want to slice my fingertip. And our second bearing, I'll set these to the side. One had actually spun underneath of the other. Again, hopefully I can get this to pop out without being destructive. I might have to get a pry bar and help it out of its happy little house a little bit. All right, that ought to have her. Ought to, but not. And there we go. All right, so let's recompose and take a look at what we got. All right, guys, so here's what we've got. As you can tell, our rod bearing was totally destroyed, as you can see from the jaggedy edges here. The fact that it is worn so thin, and the fact that it actually, the bearing had actually spun under itself. That's why we call these spun rod bearings. For you that don't know the terminologies used. What happens is when there's too much wear abuse, a bearing surface is starved for oil lubrication. The wear gets higher and higher and higher to the point where this bearing, which is supposed to be 1/2 in each half of the large end of the connecting rod, can actually spin. One piece spins under the other, which it's machined itself pretty tightly together. And once that happens, you've got excessive play, excessive room between the bearings, the connecting rod, and the crankshaft, which causes it to knock back and forth with that extra slack in there, as you saw earlier when I grabbed the rod in and wiggled it. So, notable things about F-Series engine connecting rods and pistons. As I showed you, we can unbolt the rod and push it completely out of the block, and we can install the rod and piston as an assembly into the block, much like every other, or basically every other engine out there. Another thing of notoriety is the fact that these rods are asymmetrical. As you can see, the actual big end that attaches to the crankshaft is offset of center line on this rod. If we compare that to an EJ series rod, this is an EJ22, I believe, you can see that the rod is symmetrical. Everything is perfectly mirrored across the center line. But on the F-Series engines, they have an offset rod. This has been the cause of a lot of weakness in the F-Series engines, is due to this rod design. I'm not exactly sure if it is due to the dimensions, the casting, or if it is just due to the fact that this is an asymmetrical rod and it loads too much pressure on one side or the other and causes them to fail. But there's been a lot of issues with rods bending in the F-Series engines, especially in the turbocharged applications when you add more boost and make more power. If you look just really quickly between the two again, you can see that the EJ22 has a much beefier connecting rod than the FA20. It's both thicker and wider. That's due to Subaru trying to take as much rotational mass out of the engines to help improve fuel economy, but still trying to keep the engine as strong as possible. But again, as I said, it has been a point of weakness in these engines. We can look really quickly at the piston head. As I noted before, you have more deeply exaggerated valve reliefs here and here, but you also have this wedge-shaped or triangular-shaped cutout. This is where the direct fuel injector sprays the fuel into the combustion chamber. That's why this piston is shaped this way. As compared to the EJ22 piston, you see the valve reliefs in it, but they're not as deep, and basically the piston is flat-topped, where the F-Series engine is a bit dome-shaped. Aside from the size difference, of course, being that this is a 2.2 liter and this is a 2 liter. So another thing of notoriety on the connecting rod end, let me see if I can, I can't bust this cap loose, but you'll be able to see it. So on the connecting rod on the big end, as you can see on the EJ, it is a machined surface between the cap and the rod. There is a pronounced parting line, and it is machined this way, as most connecting rods were up until about the last 10 years or so. And they've gone to something that's become pretty popular. I know that Chrysler uses them. I'm not exactly sure how many manufacturers use them, but these are called a crack rod, or a cracked rod, if I can get the camera to focus. But as you see, there's no machining in this. They forge the rod. I say forged, they're not forged, they're cast. These are cast rods. They cast the rod as a solid piece, and then they make a machine section into it that when you apply a slight force will actually fracture this cap. And as you see, we have a very rough surface and just where the casting snapped. It just cracked, natural crack. No two rods separate the same. The rod cap cannot be misplaced or mixed up because they only will go back to the original rod that they broke off of. They're supposed to be, I've heard arguments that this is a stronger design than a machine parting line, that because these break due to the casting, and they have lots of different little nooks and crannies that pinch back together rather than a flat plane, that it's supposed to add some strength to the connecting rod, but not sure exactly how true that is. Go ahead and throw the fasteners back in here. As you see, these are a bolt with, as I said before, an E14 inverted Torx head on them, whereas the EJ series used, I believe, a standard, I think it's a 12mm hex headed bolt or nut on a stud. Some of them are a bolt through. I think aftermarket ones you can get them with a stud with just the nut on the back. Let me see if I can find a fish out of 12mm real quick. All right, so yeah, you can see it's just traditional hex 12mm nuts on the cap on the EJ rod. Let's see if I can get this to come apart. We got it to come apart. As you can see on this one, we've got some scoring on the bearings. This engine actually blew two rods through the block and still ran on the back two cylinders. And I can't remember if this is number 3 or number 4, but 1 and 2 came through the block. As you can see, they're scoring here. Someone ran that engine out of engine oil. And you can see a little bit of scoring on the inside. But you have, well, these are actually studs in here. And then your cap goes through. Like I said, though, you see that's a perfectly machined flat plane on the connecting rods and where they meet on this EJ compared to the crack rods on the F-Series engine. So yeah, there you go. That's a little bit of a rundown in the differences between EJ internals and FA internals. But the main part of this video was on this spun rod bearing and looking at the damage it caused. We'll look at the crankshaft really quickly, and forgot to give you a look at the inside of the connecting rod where the rod bearings had spun. It will booger up the inside of the connecting rod as well as booger up the crankshaft. Let me get the macro lens out here too to give you some really nice shots. But that's the inner part of the connecting rod where the bearings had spun. Not terrible. The machine shop probably could polish that back out and reuse that rod, as long as the rod is good and not out of shape or any other issues from it knocking, depending on how long it knocked for with that spun bearing. All right, guys, this is the surface, the rod journal on the crankshaft. You can still see the reflection of my finger. It's not completely destroyed here in the center, but on the edge, that really dug in and tore up a pretty good groove here. Not sure if this crankshaft is salvageable or could be salvaged, but not going to worry with rebuilding this engine. It was just something for educational purposes to tear down to show you guys. But I've seen them much worse than this. I've also seen them not as tore up as this, just depending on how quickly you catch the knock and how quickly you take the engine out of service once the failure has occurred. And here are those rod bearings. Again, they are super, super chewed up, as you can see. Way thinner than they should be, of course, because lack of lubrication, friction ate them away, giving us this jagged edge here. You can see a lot of pitting here as the bearing material started to scald and come apart. Looking at the other bearing here, you can even see even more evidence of that, where chunks were actually starting to come out of the surface. And as I showed when I took the connecting rod off, the bearing had actually, This is how the bearings were. One half had actually spun underneath of the other one, and we're in kind of a half moon shape deal. That allowed lots of slack on this side and allowed the connecting rod to beat back and forth on that slack against the crankshaft. So there's the parting line on these F-Series engines, the crack caps. That side isn't lining up quite as well because I think that's where I was prying against it with the pry bar to push the connecting rod out. As you see here, it fits a lot snugger. If it was, the bolt was in there and it was torqued to spec, that line would nearly disappear. But as you see, it is a really jagged surface. You can see the casting, and you know, supposedly this is supposed to be stronger due to all those little nooks and crannies, how they go back together and bite into one another once you put them together and bolt them in, but not too sure on that. Again, look at it. Here's a look again at the surfaces where the bearings were spinning. Not terrible. Not sure if the rod's salvageable, but again, doesn't matter at this point. And really quickly up close, I'll show you the parting line with EJ connecting rods, how it's a perfectly flat machined surface rather than that crack cap on the F-Series. Alright guys, that'll do it for this video. As I said, in future videos we'll be doing more in-depth comparisons between the F-Series and EJ Series engines. Thank you all so much for watching. Hope you enjoyed, and I will see you in the next video.